All right, good morning, everyone. Please make sure that you have your headphones in. If you do not have your headphones today, please make sure that you turn on the closed captions option. This video is going to explain to you how we can identify polynomials. By the end of this video, please make sure that you can define and identify each of the following vocabulary terms: polynomial, monomial, binomial, trinomial, degree, standard form, and coefficient. If by the end of this video you are not sure what each of these vocabulary terms mean, then please rewind and watch again. All right, you should have your headphones in, and you should have your foldable in front of you. So we're going to talk about a polynomial. A polynomial means an expression with many terms. Okay, poly is a prefix that means many. You could also have a monomial, and a monomial could be a constant, such as the number 8, a variable, such as the letter x, or a combination of both, such as 8x. Mono means one term, and again, that could be a constant, that could be a single variable, or that could be a combination of a constant and a variable. But again, just one term. If I have a binomial, bi, that prefix, means 2. So a binomial is a sum of two monomials. Okay, so for example, 4x plus 5. I have two terms. One term is 4x, one term is 5. So I have two monomials. This could also be 4x plus negative 5. A trinomial has a prefix of the word tri, and tri means 3. So a trinomial is a sum of three monomials. For example, 2x to the second power plus 7x minus 4. This is a monomial, this term is a monomial, this term is a monomial. When I have 3, I have a trinomial. So now let's talk about degree of a monomial. Degree means the sum of all the exponents within the term. So here I have a monomial. I have a single term. I have 4x to the third. Well, the exponent here is 3, and I only have 1. So that means that the degree of this monomial is 3. In this example here, I have another monomial, but I have two variables, x and y, each with their own exponent. So I have 4x to the third, y to the second. My exponents are 3 and 2. The sum means I'm going to add that exponent 3 plus the exponent 2, and this term will have a degree of 5. Now, when we have a degree of a polynomial, right, when they ask for that degree, they want the greatest degree in the polynomial. So I have 4x to the third, y to the second, plus 5x to the second y plus 6x. If I look at this term first, I know that my degree is 5. 3 plus 2 is 5. Here I have an exponent of 2, and the y has an exponent of 1. So 2 plus 1 would give me a degree of 3. In this term, I have one variable that has an exponent of 1. So this degree would be 1. If this term has a degree of 5, and this term has a degree of 3, and this term has a degree of 1, the greatest degree is 5 from the sum of 3 plus 2. If you are asked to write a polynomial in standard form, that means that you are going to take the degrees in order from greatest to least, and sometimes that is called descending order. So I have a trinomial here, and what I'm going to look at, I have a polynomial. I have 4x to the fourth as one term. I have a negative 7 as another term. I have 5x to the second y as a third term, and the fourth term is 6x to the fifth. If I'm looking about degrees, I have a degree of 4 here, I have a degree of 0 here, I have a degree of 2 plus the exponent 1 here, so 3 and 5. So my greatest is 6x to the 5th, followed by 4x to the 4th, followed by 5x to the 2nd y minus 7. So my exponents, or my degrees, go from the largest, which is 5, and they go down 4, then here I have 3, and then 0. The leading coefficient, and again, your coefficient is your number in front of your variable. So your leading is where you start. Your first term in standard form is 6x to the 5th. The coefficient is the 6, or the number in front of x. All right, so now if you open up your foldable inside, we have practice finding the type of polynomial. So is it a monomial, a binomial, or a trinomial? And we have practice finding the degree. So here I have two terms. I have 4y, I have 5x to the 4th z. So the type would be a binomial. The degree is 5 because I added the exponent 4 plus the exponent of 1 on the z, and that is the greatest degree. Here, I have three terms. I have 6x to the 3rd plus 4x to the 2nd plus 3. Three terms, or a sum of three monomials, is a trinomial. And so if I was talking about the degree, all right, this is written in standard form. The greatest degree is 3. For the next one, I have a single term. That makes this a monomial. And the degree is 0 because it is a constant. Now that differs from the example underneath that says 8a. Again, this is a monomial. It is a single term, but I have a variable a. The exponent is not clearly written. That means the exponent of this is 1, so we have a degree of 1. It's all about whether you have a variable or not when we're talking about degree. In the next example, 6x minus x plus 4, I have three terms. So that means I have a trinomial, or a binomial, because I can combine 6x minus x. So what started as a trinomial can be simplified. 6x minus x is a binomial. 6x minus x is 5x plus 4. The degree is 1 because the exponent for the x is 1. In the last term, I have 26b to the 2nd. That is a single term, making it a monomial. The exponent of the only variable is 2, so that means I have a degree of 2. On the bottom part of this page in your foldable, we're going to practice writing these polynomials in standard form. And standard form, again, means writing the degree from highest to lowest. And then we're going to identify the leading coefficient. So here I have a trinomial. If I'm going to write this in standard form, I'm actually going to take the highest degree, which is 6, followed by 9x to the 2nd, followed by 4x. That will put my degrees in order from greatest to least. My leading coefficient is 3 because that is the number in the first term. In the next example, I have a polynomial. I have a degree of 0 here because it is a constant. I have a degree of 1 here. I have a degree of 1 plus 1, all right, which would be 2. I have a degree of 1 plus 2, which would be 3. So I'm going to actually just take this and write it in the reverse order. So now my exponents are going from highest to lowest in degree, and my leading coefficient is 8 because it is the number in front of my first variable term. Here, in this example, if I'm writing it in standard form, I have a degree of 1 here because y has an exponent of 1. Here it's 0, and here it's 2. So I'm going to go 2, 1 to 0. My leading coefficient is 5 because it is the number in front of the variable on my first term. For the next one, all right, I have a degree of 1 here. I have a degree of 2 here, and I have a degree of 0 here. So I'm going to rewrite it so that I have negative 7x to the second plus 6x plus 8. And then the leading coefficient is negative 7. Be careful of the sign in front of that term. This subtraction is the same thing as adding a negative, so make sure you keep the correct signs. And on the last one, I have a degree of 3, a degree of 5, a degree of 0, and a degree of 1. So I'm going to rewrite that in order from greatest to least. So I'm going to have x to the 5th plus x to the 3rd minus x plus 3. Again, make sure you're keeping your signs. The leading coefficient, I do not have any number in front of x to the 5th, so I know that that means 1. All right, I hope this was informative and helpful. If you missed any notes or if you need anything to be told to you again, just pause and rewind and press play.